Hi everyone and welcome to Issues in Cosmogony, Week 1. The title for this week will be Knowledge, Science, and Belief in God. It really serves as an introduction to the class and a refresher in a few things, but all in all it's going to be a moderately contentious class because the very title of the class is Issues in Cosmogony. Now, cosmogony, of course, is just the origins of stuff inside of the cosmos, and so there's plenty of, well, if you will, issues that various people have with various positions, and there's a lot of things we don't yet know about cosmogony. Many times, unfortunately, this is pitted as modern science versus God. So basically, we're going to try and take a different approach than, well, modern science versus God. But it's going to be, well, basically, you can see in bullet point 2 there, what if we grant all of the results of modern science? Virtually all of them. And instead of doing what many people of faith might do, which is one where they try to cast doubt on scientific explanations, or they shun it, they reject it, or they even aim to portray it as a demonic enterprise. But let's say we actually flip this whole thing around and said, you know what, we accept everything. We accept it all. We know that certain things we'll hold with a little less confidence, if you will. And what would that do for belief in God? And what should this do for belief in God? I mean, classically, there were various arguments for the existence of God via the cosmological argument, moral argument, ontological argument, teleological argument. There might be one or two more, but surely it's time we put these silly arguments away. I mean, what are those things that were done in the medieval Dark Ages or something? Well, we're going to see actually that modern science, surprisingly enough, brings all of these questions back to the forefront. And so, you know, that's what we're going to do in this course. We're going to take that approach, and we're not going to fight. We're not going to be fighting the science, but we're going to be asking, what does this mean? That's not really a question that is asked a lot in science. What does this mean for Christianity? What does this mean for God in general? And so, yeah, but first of all, if we're going to grant and accept only what is, well, science, we're going to have to play by certain rules. The only problem is that what about new ideas? Because it's certainly one of the challenges of saying what is science and what isn't. There isn't really a clear cutoff point that says, well, anything above this line is science, anything below is not science. It's really, instead of black and white, it's more of a spectrum of confidence in ideas as they are tested and evidence supports them. And we'll get into that a little bit more and apply this loosely and adjust a little bit to the intelligent design movement and some of the ideas that they've had. But basically, if your idea is not supported by evidence, even if it was at one point a fairly confident idea, it's dragged down, and it could even become discarded, rejected, and ultimately labeled as pseudoscience. So there's some rules, and we're just going to go through that, just a review of that. Well, first, you know, again, just ask the question, what is science? And there's so much confusion. It's not really confusion amongst scientists who actually do this, but a lot of people who don't do science seem to have a lot of different and even conflicting definitions of what it actually is. It's certainly not a collection of facts. And that's not even really the right kind of language. Sure, there are scientific facts, but really it is this body of knowledge and a process that builds upon this knowledge, and it's never finished. It's a continual process. It's always being refined and expanding our knowledge of what is in nature, and certainly we come up against the limits of our ignorance on a daily basis, those that do science. And the process is even kind of fairly similar to how children interact with the world. They go and they make some kind of observation. They consider the evidence of what happens, they test their ideas, and they hold on to those ideas that work, and ones that don't work, they readily discard. So if they can come up with a clever way of of testing whether or not their parent will give them ice cream when they behave a certain way. That's pretty much the scientific process. But the deal is that there are specific rules, and I kind of use that loosely in quotes. But you have to play by the game. You can't just make up your own rules and come in and say, "Hey guys, I'm doing science now." First, though, I'm going to ask, what is this a map of? It's obviously, you can see the various continents, and you see some of the parts are colored slightly differently. America is fairly blue. Looks like South Africa is also blue, and some other parts of the world, and so forth. Northern Africa would be green, and then a lot of the Middle East is green. So you might start to get the sense that this is actually a map of world religions. And so these are just many of the major groups that are characterized. But there's something about science that even transcends some amounts of these faith commitments that various people have, where there's not a map of world science. If there's a map of world science, it would just be one color. And sure, you can have dissenters here and there, and those are certainly welcome. And if their ideas hold up to scrutiny, scientists change their minds. I've changed my mind as a scientist a lot of times when new evidence comes in, or I find that my position isn't really that well supported by. So, some key characteristics. I'm not going to spend too much time on this slide because we're going to get into each of these in a little more detail. But natural world. That's what science studies. And what is the natural world? Well, how about matter? Or forces, fundamental forces that act on matter. Or energy, those are kind of more physics, or the biological world, or humans, human society, and the products of that society. Those are all natural things. And that is in contrast to supernatural forces and explanations. And science can't really study those types of claims unless they have some kind of effect on the natural world. Then you could test that to some degree, but really science can't support or contradict the existence of supernatural entities. There are limits to this process. And certain questions can't necessarily be answered in a scientific way. No questions are off limits, but there might be some limits to what the scientific process can tell us about life. So there are certainly some limits to it. But at the same time, this is just simply what science is. And it aims, obviously, to explain and understand. So, I mentioned this just briefly, but basically no scientific idea is ever, like 100% proven. It's not as if, something starts off as a scientific theory, and then with more evidence, it becomes a law. That's a completely wrong understanding of what a scientific theory actually would be, first of all, but it also implies that scientific laws are these ultimate ironclad understandings of reality, and no, they're not. They describe something in a very, very consistent manner, enough to be called a law, like Newton's law of universal gravitation, but Newton's law of universal gravitation does not work universally. It doesn't work at really small scales. Whenever you get too close, his law doesn't hold up. You have to add a correction term to it. Or if you go to really, really large scales, or things moving very quickly, his law doesn't work, but it's still called a law in science. And so basically, we're always testing the limits of our ignorance. We're always going up against the boundaries of what we do not know in this process, and it aims to explain it and understand it. And sometimes ideas that are fully accepted today, they might be rejected or certainly at least modified, like the example I just mentioned with Newton's law of universal gravitation. It wasn't rejected, and it's still used today, for example, by NASA in launching satellites, but it needed some modification to describe some of the extreme conditions that it could possibly apply to. So, but that kind of leads some to attack science and say something like this. So here's, for example, Ken Ham in the New Answers Book 1, he wrote in 2006. He said, "Skeptics often claim the Bible is not a science textbook. This, of course, is true because science textbooks change every year, whereas the Bible is the unchanging Word of God, the God who cannot lie. And then a quote from Al Mohler, and he gave a talk in 2010 called "Why Does the Universe Look So Old?" And these are both young Earth creationists who do disagree quite a bit with science. So they have to find some justification for that. And here is what Al Mohler suggests. Similar to Ken Ham, he said, "Just remember, first of all, that science has changed and has gone through many transformations. The assured results of modern science today may very well not be the assured results of modern science tomorrow, and, I can promise you, are not the assured results of science yesterday." So what are these two evangelical Christians getting at in their particular quotes and challenges? They're saying, oh, you all are just changing your mind. And that is a very, very wrong understanding of how science is actually done and how it builds upon itself. It's not as if in the 1990s, everything that we learned in the 1980s was all of a sudden flipped upside down on its head, and we rejected it all and started from scratch. And then, then at the beginning of the millennia, in the year 2000, we threw out the 1990s, and we came up with everything. No, that is completely wrong, and this is a very misleading way to talk. Because scientific ideas are reliable, despite the fact they're subject to change. And you may be drawn to the little cartoon on the right. That's typically how the science news cycle works. Scientists, if they're doing good science, they are very careful to draw their conclusions based upon what the evidence actually supports. However, what can happen is that sometimes gets blown out of proportion. And so here's just a small little comic. Starts with your research. A is correlated with B, P equals 0.56 given C, assuming D, and under E conditions. And so then, let's say the university PR department gets and then they say, scientists find potential link between A and B. Okay, that's a little bit different than what you said. They left out the C, D, and E conditions, and at least that was moderately accurate, though. But then the news gets a hold of it, and they say A causes B, say scientists, and that is definitely not what you originally said. And then it gets to the internet, and then that's I don't know, some discussion board, scientists out to kill us again. And then on cable news, A causes B all the time. What does this mean for Obama or Trump or whoever it may be? And then the local news might be even different. And then by the time that it's watched by your grandma in this comment, she said, "I'm wearing this tin hat to ward off A." And to which you just palm your face. And so, but these ideas are very, very carefully tested when science is done properly. And ideas that have gained scientific acceptance, they have gone through many different lines of evidence. And many of them even work in a practical sense too, like airplanes, antibiotics, vaccines, etc. And they have survived. This process of scientific inquiry is rigorous. It follows biblical principles, you could even say. And not the principles in the things that you might see in the news or pop sci articles. So what is part of this rigorous process? Well, it works with testable ideas. Really, only testable ideas are within the realm of science. If your model has some aspects that are testable and some that are not yet, that's fine. That's perfectly fine. Like, for example, inflationary cosmology would fit that bill, where some aspects of it are testable. It makes some predictions that we can measure now, but there are some things we can't test now, and we might not ever be able to test. And that was true with Einstein and general relativity. Like, he thought there's no way we'd be able to detect gravitational waves because of how small he predicted that they would actually expand or contract space itself. But we've been able to do it 100 years after he came up with his predictions. But basically, you have an idea. It must generate some kind of specific expectation. Like, this basically, is there something we can go out and test that is consistent with your idea, that would help establish your idea, or that would help falsify your idea? And sometimes it takes a lot of work, and even new technological things to test. But then you might even need to make assumptions to test your idea, and then you need to test your assumptions. And so all kinds of things happen like that with radiometric dating. That would be a great example of there are certain assumptions that one makes, but you can test those assumptions and find that your initial measurements are actually reliable. And then this is also a bad thing. Let's say there's some kind of explanation that you have, and it doesn't matter what you find. Your explanation is always true. That's not testable, and that's not within the realm of science. That would be like, for example, many aspects of uh, creationism science can fit that bill, where it's basically no matter what we find, it's always true. That's not that's not a scientific idea that you can test, you can falsify, you can refine your model, because it made no predictions in the first place. It's just you look around and you say, hey, look, this is consistent with my model, but it made no new predictions in the first place. And astrology is the same way, perhaps even more extreme, where this will happen on such a day. It's so incredibly vague in the first place. And for those who believe in it, it doesn't matter if the thing actually happens or not. They might be able to fit something that happened to them to fit into the pattern. And if they don't, they just forget about it and say, yeah, it's not perfect. It's still true regardless of what happens. And that is not scientific. And obviously, after you're testing your ideas, you must actually test them after coming up with an appropriate test. And you need evidence. Something to support your idea, obviously. Presumably, many different lines of evidence that are based off of different physical processes by many different people from different research groups around the world. And what really goes into testing their ideas, especially today, sometimes people do very almost extreme things where they spend years working on a single experiment, or traveling to Antarctica to measure the amount of carbon dioxide in an ice core to see what the concentration of CO2 was historically in the past, say, 10 to 20,000 years. Or collecting DNA samples from thousands of volunteers all over the world that either have different conditions or they're just genetically diverse. And so there's a lot that goes into this process of finding evidence. If you don't have evidence, that's like what am I thinking of? Just like the currency of science, ultimately. Then part of the backbone, evidence, obviously. And if your idea is not supported by evidence, it's ultimately rejected. And, it's certainly I think a praiseworthy pursuit that really, if you have an idea, its acceptance or rejection depends on evidence relevant to it. It doesn't depend on popular opinion or tradition or dogma. It doesn't matter. None of those things actually matter when you're talking about scientific ideas. So that's part of the reason why you don't have a map of world science. Because it doesn't matter what X, Y, or Z believe or think is true. It only matters what this evidence actually supports. And if you protect your idea from testing, or you only have one kind of group testing them that already have a vested interest in the outcome, that's certainly not a part of good science. And then ultimately, this isn't done alone. It's done in the context of a broader community. And that's a very, very important thing, to interact with that community and to have your ideas be scrutinized by that community. And so certainly that helps provide some kind of cumulative knowledge base. So science is not changing its mind continually. There is this cumulative knowledge base that's being built upon, and there are, ideas that are accepted and allows it to build upon itself. And also this community provides a system of checks and balances. This is through multiple ways, through peer review and repeatability. So if someone actually doesn't like your results, guess what? It doesn't matter how they feel. If they can go out and support and justify that your results do not support your conclusions, then that's legitimate. You can do that. You can challenge people's ideas. And at times, it could be chaotic, but at times this could be really slow. Take, for example, that little news blurb, little comic strip where A is loosely correlated with B. That's really slow. That's not what people want to put on the local news, or even your university's PR system actually wants to do. They want to say, hey, we found this great and amazing thing here, but that's generally not how science tends to work. It usually doesn't happen in these giant leaps of world-changing leaps. You might see this where, oh, new fossil upturns the evolutionary history of mankind. That's basically been an inflated claim. And the process is really much slower than that, and sometimes it doesn't make a lot of sense. It can be kind of chaotic. But this is how science is done. And of course, it leads to ongoing research. It's never going. It doesn't end with the most recent edition of a college textbook. Certainly, and for a science textbook to actually not change in the sense that Ken Ham suggested would be the death of science. And so typically what you find happening is when one question is answered, it inspires deeper and more detailed questions to figure out more. Whenever good science is done, typically that's what happens. Here's John Wheeler speaking, the quote on the right: "We live on an island surrounded by a sea of ignorance. As our island of knowledge grows, so does the shore of our ignorance." And so, like, for example, when the chemical structure of DNA was first discovered, that led to a ton of research. I mean, people are still, it's one of the most productive areas of research that we've come across in research. Now, I'm going to talk about something next where scientists, you need to behave scientifically. And I put that in quotes, but you can see here this little comment. He said, everyone gets in as long as they behave scientifically. And there's a little sign on the wall. It says, all patrons must expose their ideas to testing. Thank you. So it's not an elite enterprise where you have to be part of a club and have a special pledge to Darwin or naturalism or anything like that to be taken seriously. But it's open to anyone. Like I mentioned, there's not a map of world science, and it does benefit a lot from people from different backgrounds. But it only works when scientists behave scientifically. So what do I mean? Well, here are basically 5 little guidelines, and I'll just kind of break these down very briefly, but pay attention to what people have already done. To be grossly unfamiliar with what people have done and to dismiss it in a very, very casual way is not behaving scientifically. For example, Michael Behe, when he was on trial in the Kitzmiller versus Dover trial, he was talking about how the immune system was incredibly complex and it couldn't have come about via slow changes over time. And so he was presented with a paper after paper after paper after textbook after textbook after peer-reviewed paper in textbooks. And he was not paying attention to what people had already done, and he dismissed it very flippantly. That, despite being a scientist, that was not behaving scientifically. And obviously expose your ideas to testing, assimilate the evidence, openly communicate ideas and tests to others, and then play fair. Act with integrity. I mentioned how this is cumulative. If you want to discover exciting new things, you need to know what people have done before you. So you have to study your field extensively and be familiar with what questions people are asking, what are they publishing, etc. Obviously, you have to expose your ideas to testing. So, and submit it to journals, the best journal that you possibly can. I see this in certain ways where certain Christian scientists will take their paper, whatever they want, and they'll submit it to an obscure journal, or they'll make their own journal they don't actually let their ideas be scrutinized by experts who are likely to disagree with them. That's what happens when I publish papers in biophysics. That's, I send it to the best journal I can, and they scrutinize the heck out of my paper. Because think about this, if your paper is being reviewed by other experts in your field, that means they're your competitors. They don't want your paper to get published, but they act with fairness and integrity, and they scrutinize the heck out of it. And if your competitors can't disagree with you, then you're on to something good. And obviously, you have to, not free to ignore evidence, and you might suspend judgment on your idea, or revise or reject your idea, or consider other ways to explain the evidence. But certainly, ignoring evidence is not something that one should do. But at the same time, you have to be aware of how the scientific community would or would not actually be aware of evidence. So an example would be with anthropogenic global warming, or have humans caused or influenced the global warming that our planet is currently facing. Someone can come in and say, hey, what about the sun? Have you thought of the sun? And someone uses that to justify rejecting the consensus of the scientific community without realizing and this is the key part, without realizing that, yes, scientists have written hundreds of papers upon the sun and have studied it in so much exquisite detail that it would go far beyond what most of us would be able to understand. So all of these have to be done hand in hand. You don't just get to come in and say, y'all haven't thought about the sun, when they have for decades upon decades and done a lot more rigorous studies. So, but, you know, with the evidence that's out there, you're certainly not free to ignore evidence. It's pretty bad. And then openly communicate ideas and tests to others. Creating alternative journals where your ideas are not tested, communicated, and critiqued by others, where others can build upon those ideas or double check it, that's not behaving scientifically. So, you know, various young earth creationist organizations create their own journals and just speak amongst themselves in their community, and they don't allow their ideas to be scrutinized by the outside scientific community. If they really are legitimate ideas, they will win over even the grumpiest of scientists over time. And most scientists are generally grumpy. The Discovery Institute and their Biologic Institute, they have their Biocomplexity as their own journal. And there was a recent paper that was published by a mathematician, Ewert was his last name, and several geneticists read his paper who are also Christians, but they read it and found several fundamental flaws in it of a purely technical nature, not even with his conclusions, that would have been caught by legitimate peer review by experts in the field. So, and also act with scientific integrity. Hiding evidence, selectively reporting evidence, faking data, not permissible. There was a paper, maybe 2017, related to, it was related to vaccines and autism, actually. The original one by Andrew Wakefield was retracted for its fundamental flaws and wrong conclusions. But this researcher in 2017, it was passed around the blogosphere of those who are anti-vaccine and whatnot, but the paper was almost immediately retracted because it was found that he basically doctored his images, he doctored his figures, he even copied images that he used from previous papers into this more recent paper and said they were new data. So that is so shameful and is to be rejected with the utmost passion, if you will. That's not behaving scientifically. So, how about intelligent design? This actually gives the appearance of being scientific, but let's just ask a few questions about the movement as a whole. Of course, there's a comic on the right, God throws the creationist a curveball. Let there be evolution. But let's just go through this list of what is science and asks, how is the intelligent design movement doing? Is it a scientific movement, or is there something more to it? There's nothing wrong with it not being scientific, but it's certainly being endorsed as being scientific and gives the appearance of being scientific. So first, does it focus on explaining something about the natural world? Yeah, of course. It's promoted as the best explanation for the diversity of life, the origin of life, and various molecular features of many organisms. Okay, good. How about next? Does it aim to explain the natural world? Well, yeah. It aims to explain it. For example, the bacterial flagellum is so irreducibly complex that the pieces of such cannot actually exist by themselves, and it has to be popped together in one instantaneous step by this intelligent designer. Now, it doesn't say anything about how the designer might have constructed it or who the designer might even be, but the argument is just that, hey, all of these things in the natural world, these natural processes, are so incredibly unlikely that at least processes that we know of can't account for it. But I put up something here on the right, and these are two various studies done on the bacterial flagellum motors. And so here, for example, the paper on top is a recent paper that talks about the evolution of higher torque and this particular type of bacterial flagellum motors. And so this is tracing piecewise additions that lead to a bacterial flagellum. And so, I mean, what are we to do with the intelligent design explanation here? It gives the credence of saying, hey, look, this is impossible. Here's the reason why this is impossible. But yet, what happens when explanations come about? Do we just look at this and say, oh, no, 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 you're wrong? So that gets into kind of the next problem. Are the ideas testable? Well, you know, scientific ideas, they generate specific expectations about things in the natural world that would support or refute the idea. But in reading through, let's say, for example, evolution news, everything that is ever found supports intelligent design. It doesn't even say who the designer is or how he operates. It doesn't generate any kind of specific observations to figure out whether it's correct or incorrect. And so, for example, here's another little comic. And it's today class. We're going to discuss the scientific theory of intelligent design. God did everything, class dismissed. And there's no actual predictions other than just, we should find processes that science can't explain ever. That's really pretty much what the argument is. So does it rely on evidence? Well, I mentioned the one with a testable claim. A testable claim, for example, that existed and was made popular by Michael Behe in the late 1990s was that the bacterial flagellum was irreducibly complex, the pieces and parts. You can't just have a piecewise bacterial flagellum motor. That was a testable idea, and that idea has been falsified. But ultimately, you know, the central mechanism of ideas that there is none. No one has ever said what the mechanism actually is, how this thing actually works. It's just there's some science going on here, then a miracle occurs, then some more science occurs on the other side of the coin. And that's really all the main argument that is made, at least in relevance to the. So is it involved in the scientific community? No, they're not. As I mentioned already, they've created their own journal that they publish in and review each other. And they're all devoted collectively to promoting their own idea. They don't subject their ideas to the scrutiny of the scientific community. And if the scientific community criticizes their ideas, they just criticize the criticism and say, you all are wrong anyways. So that certainly is not behaving scientifically. And does it lead to ongoing research? Well, the idea itself hasn't generated any actual predictions, if you will, or any scientific discoveries, other than just frustrating the scientific community enough that, hey, we know a lot more about the bacterial flagellum than was known in the early 2000s. And so, you know, and this is kind of how it's thrown out, you know, and the comic on the right, this is teach both theories, let the kids decide. So here is chemistry and alchemy. Here is phrenology, where you control things with your mind, and here's neurology. Here's E equals mc squared and magic. And here's astrology and astronomy. So, would it be fair to subject the kids to such? I mean, all of these ideas have one scientific idea and one pseudoscientific idea side by side, and intelligent design does not fit the bill in any way whatsoever of what is science. So it's clear that it doesn't follow the rules of science, and it's not science. But does that mean that it's wrong? Well, no, it actually doesn't. Not in one bit. It certainly means that intelligent design is not, it's rejected as a scientific explanation for the natural world by the scientific community, which includes a good amount of Christians who are very strong Christians, mind you, and many of them accept an intelligent designer. But the main arguments and mechanisms of ID, which don't really exist, are certainly not scientific. And so, here are some concluding thoughts, at least on this part. So, yes, evidence, despite what people claim, continues to trickle in. It really does undermine this ID view. Not that there is not an intelligent designer, but that the movement of a whole as basically, hey, y'all can't explain this, therefore the intelligent designer did it, is getting weaker over time. And to many actually label the whole movement as a God of the Gaps type of movement, which I know will be firmly rejected by those inside of it, but at the same time, that's ultimately how it looks in the realm of scientific inquiry, as I've explained it. And ultimately, though, many creationist organizations, including both Christian and Muslim ones, continue to claim that all new evidence supports their viewpoint, and they all contradict each other. Let's say I'm reading a Muslim apologetics website. Everything that comes in, oh, this confirms the Quran, this confirms the Quran, and then I go to a Christian creationism type of website. Oh, this affirms our interpretation of the Bible. This affirms our interpretation of the Bible. This affirms our interpretation of the Bible. So I've seen that with young Earth creationists and old Earth creationists. Both of them claim that everything that is ever measured supports their viewpoint. That doesn't make sense. None actually provide a way to decide between them. They make no predictions and don't of their scientific explanation. So basically, there are two principles, Povarnik's principles number one, which is the greater the uncertainty in any given area of science, the greater the likelihood you could find an article on a creationist or faith-based website. It's not true with all faith-based websites. Many of them have very good science on them, but many of them are not. Povarnik's principle number two: scientific inquiry cannot falsify any holy book, gods, or supernatural entity. It can only provide constraints on how one can interpret the words or actions of that entity or being. So, science can't falsify the Bible. It can only provide constraints on how you could potentially read the Bible, for example. It also can't falsify the Quran, but provide constraints on how you can and cannot read certain parts of the Quran. There must be some other kind of way to actually decide between them, but science is not going to do it. So, there's two sides to this picture. On the left is science, and on the right is faith. Let's look at faith first. So it's you start, you get an idea, you ignore contradicting evidence, you keep your idea forever, the end. Maybe there's not contradicting evidence. That could be a little misleading. I just grabbed this from wellingtongray.net, whatever that is, or whoever that is, I'm not sure actually. But let's say you start, you get an idea, you keep your idea forever, the end. That's basically what it is. And certainly we don't want our faith to be a blind faith where there's really no evidence or all the evidence is contradicting what we actually believe. That would not be, I think, a type of biblical faith that is encouraged. And on the left, you have science, where you start, you get an idea, you perform an experiment. Well, does the evidence support the idea? No, bad idea, go back to the beginning. Yes, maybe you can create some kind of theory. And then try to apply your theory to the universe in a broader way. Discover new evidence. Can the theory be modified to explain new evidence? If you can't, then hey, revolution! Time for a new idea. And that's really exciting part of science. That is really exciting. If there start to be too many anomalies in your idea, then hey, that's really exciting. Or if you can modify your theory or elaborate it a bit in some kind of way, or for example, with the theory of evolution, we know many more genetic mechanisms than we ever did even just decades ago. And so can those mechanisms help account for some things that we weren't able to before? If yes, good. Use that theory to better explain the universe. If not, revolution. So that's kind of the fun thing. But I'd like to propose that it's a bit more, the relationship between science and faith has been mischaracterized to be something like this. So while this can generally capture how things can go in the science dialogue and the faith dialogue, it kind of looks almost something more like this, where they're almost speaking of two different things. It's almost like two different languages, and neither language is better or worse. But let's say the sun is bright. Because why? Well, one explanation is God loves us and wants there to be a bright sun. Or, the quote scientific explanation is that the sun is a huge ball of fusion reactions that give off a great deal of energy in the form of light. Because why? Well, because God loves us and wants there to be a huge ball of fusion so there can be a bright sun. Okay, but ultimately why? Why is that happening? Well, because gravity squeezes hydrogen atoms close enough together to create a fusion reaction. Because why? Well, because God loves us and wants fusion to result from a big ball of hydrogen so there can be a bright sun. Or is it, because gravity is a fundamental force of nature that affects the hydrogen atoms in the sun? Because why? Well, we don't know. Or is it because God loves us and wants there to be gravity so there could be a bright sun? So these really are two different sides of the coin. Neither are necessarily wrong. I mean, everything on the left is absolutely correct. But because everything on the left is absolutely correct, what does that mean for everything on the right? It doesn't mean that much. Can everything on the right still be true with everything on the left being true? Certainly. And these are like speaking two different languages or two different sides to a coin. So we're going to spend a lot of time looking at the types of things on the left side of this diagram throughout the course and kind of asking, well, what does that mean for things on the right side? So, just in summary, the structure of the course, your grade will be determined by your discussion posts in weeks 1 to 7. So they're 10% each, and then your final paper. The discussion posts, because there aren't any other assignments, they're going to have a longer requirement than usual. And your final paper will be going through these 6 areas covered in the class, and you'll create an LM table similar to how the authors of the book have done so. And so here's the table reproduced here, where they have an LM scale, which is basically least likely or most likely to support the existence of God. And so there are the different categories we'll look at, and your paper will be to basically construct your own table. And in as neutral as way as you physically can. I know that you have certain backgrounds, and we all have internal biases, and that's fine, that's fine. I mean, the authors do as well. So, I mean, it's not like their numbers are the absolute scientific ways that you can answer this. But we're just going to be taking a look at modern science and say, hey, what does this mean? For God, for the classical arguments for his existence. And the authors, as you can see, rate fairly highly. They, all in all, they give an 80% more likely rating to there being a God than not being a God after looking at everything of modern science. And so, anyways, I hope that you like the course. Let me know if you have any questions.